Okay, so we just found the little diagrams for someone who drops a rock off of a cliff. Now, in ETM2, we need to come up with an expression between two snapshots. I'm going to pick between A and D. So I look over here and say, oh, I want to take a snapshot here at A, here at D, which I've already done, and I want to come up with a mathematical expression that relates the energy transfer between these two snapshots. So there's going to be some things that I need to know before I move forward. The relation, or the equation for kinetic energy is 1/2 mv squared. For UG, it's mgh. For US, it's 1/2 kx squared. What do all of these things mean? M is for mass, V is for velocity. M is for mass, G is for the 9.8 gravitational constant of the Earth, H is for the height from the base, K is for the spring constant, and X is for the distance stretched. Okay, let's get to it. To get an expression, you look at your little diagram and you ask yourself, what kind of energy do I have here? Well, let me just kind of move this up a little bit. You see what I'm working on? Hopefully. What kind of energy do I have here at that first snapshot? I have UG, so I'm going to start my expression by saying UG in the initial snapshot is equal to, now I take it over here to the D, because that's what I'm comparing. The only energy that I have is K, and that's in the final. So that's step one. Step two is look at your expressions that you have here. You don't even need the little diagram anymore. I have UG. I go over, find the equation for it. It's mgh. So I plug that in. mghi equals K. What's the equation for K? I go over here, 1/2 mv squared. And I still put the final because this is in the final case. That's my equation. Notice that some things will cancel out, or at least one thing will cancel out. The M, I have an M over here, an M over here, so that drops out of the equation. So all I'm left with is GHI is equal to 1/2 BF squared. That's ETM2. Probably the easiest of the bunch. All right.